Use a net to find the surface area of the cube. So two things, we have to use a net and we have to find the surface area. So the first thing I want to do is use a net. So I want to figure out how many faces does this figure have, and note it is a cube. What's unique about a cube is that a cube is made up of 6 equal faces that have the same exact area with the same base and the same height. Because a cube, in order to be considered a cube, all of the side lengths needs to be equal. All of the side lengths of each face. So if this is 4 5/10, this side is 4 5/10 centimeters. This is 4 5/10 centimeters. Every edge is 4 5/10 centimeters. So we need to see how many faces we have on a cube. We have a bottom base. We have a top base. And since our base has 1, 2, 3, 4 edges, we know we have 1, 2, 3, 4 lateral faces to connect to each edge of the base. So I'm going to draw my net. So I'm going to draw my base first. And there are many ways to draw a net for a cube. I'm going to draw my base, and I'm going to draw another lateral face that's supposed to be equal length because all of the lateral faces are exactly the same. And then that's my top base. And then I'm just going to draw my lateral face all connected. And I need a total of 6 because I have 6 faces here. So 1, 2, 3, 4, 5, 6. If I fold it up, it'll make a perfect cube. So I know that each edge length is 4 5/10 centimeters. So I can find the area of 1 using my formula for a square, which is area equals s squared, where my side length is 4 5/10 centimeters, and I need to square that. So 4 5/10 to the second power means my base 4 5/10 centimeters is a repeat factor 2 times. So that means I need to multiply 4 5/10 centimeters times 4 5/10 centimeters, and that's going to give me the area of 1 face. So once you multiply 4 5/10 centimeters times 4 5/10 centimeters, you end up with 20 and 25 hundredths, and area is always squared because it's two-dimensional. Centimeters times centimeters is going to be centimeters squared. So the area of 1 face is 20 and 25 hundredths centimeters. So if the area of this face is 20 and 25 centimeters, the area of this one is also 20 and 25 centimeters squared. And this one is also 20 and 25 centimeters squared because they have the same exact base and height. If you have the same exact base and height, you're taking up the same amount of area. So this one is the same thing because it has the same base and height. This has the same base and height. This has the same base and height. And then I can add 20 and 25 hundredths plus 20 and 25 hundredths. How many times? 1, 2, 3, 4, 5, 6 times. One, 2, 3, 4, 5, 6. And then I'll get my final answer, which is 121 and 5/10 centimeters squared. Now you could also, we know that repeat addition is also multiplication. So we have 20 and 25 hundredths added 1, 2, 3, 4, 5, 6 times. So instead of adding that 6 times, we can just multiply by 6. It doesn't matter where you put the decimal point in multiplication. I mean, a line of the, let me fix it. So we have 6 right here. And then we just need to multiply. 6 times 5 is 30. So we should get the same answer, 12, 13, 14, 15. 6 times 0 is 0, plus 1 is 1. 6 times 2 is 12. And then I need to put my decimal point in the product, so I'm going to count 1, 2, plus 0 is going to be equivalent to 2. And then I need to put my decimal point in the product, go 2 spaces over. So I get the same exact answer, 121 and 5/10 centimeters squared. Repeat addition is also multiplication. So now I have this surface area. How much area is the surfaces of a 3-dimensional figure taking up? That is surface area, the area of the surfaces. So that's how you do that question. Find the surface area of 1 face, multiply it by 6. You can draw your net, make sure you have the correct number of lateral face, and then go from there. And that's how you answer that question. Moving to the second one that some people struggle with, not everyone. the same type of question. So use a net to find the surface area of the rectangular prism. So you want to find the surface area. What is surface area? Surface area is the area of all of the surfaces. So if I find the area of every face, then I'm going to add them up, and that is going to be surface area, the area of the surfaces of the figure. So the first thing I'm going to do is draw a net. So I'm going to draw my base, which is 18 by 8. So I'm going to draw my base right here, and I know the base is going to be 18 by 8. And then I'm going to draw I'm going to draw the back face. So I'm going to draw the back face right here. And that's going to be 27 by 8. So I'm going to draw this back face. And it's going to be 18 because it has to connect to this. So they have to have the same exact length. 18 by 27 centimeters. And then I'm going to draw my other face connected to that, which is up here. And that's going to have the same exact area of this because they have the same dimensions, 18 by 8. So at this point, I drew 3 face. But I know that a rectangular prism has a total of 6 face, so I know I'm not finished. I'm going to go ahead and do the left and right face. So I'm going to outline my left and right face. So this is the height, which is going across 27. So the height of my left and right face is 27, and the base is 8. So if I outline it, I can see what the dimensions of that figure is. So I'm going to draw that right here. And then I know that it has to be 8 here. This 8, when I fold it up to make my figure, this 8 connects to that 8. So I know that this edge is going to be 8. And since this is 27 right here, this is connected to that, so this must be 27 as well. If this is 8, it connects to this one. I fold it up, that's going to be 8. But I need another lateral face over here, left and right lateral face, to have the exact same area, 27 by 8. So I'm going to draw another one right here. So 8, if this is 8, this is 8, this connects to that, that is 8. If this is 8, this is parallel to that, this must be 8. Now I have 1, 2, 3, 4, 5 face. I'm missing a front face, right? Because I need 6. So I can just draw that. You can draw it right here, or you can draw it right here. It really doesn't matter as long as you fold it up and it makes the perfect net. But I'm just going to draw it right here. And the area of this is going to, the base, if I outline the front, is going to be 18 by 27. This is the front. So 18 by 27. Notice that this 18 has to connect to this 18 to make that perfect net, this figure right here. So now I'm going to find the area of each one of the surfaces. So right here, the area of this, how many square units is in this? If you 1, 2, 3, 4, 5, 6, 7, 8 by 27. 1, 2, 3, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27. If I finish drawing all of these little squares in here, I'm going to see how many square units is inside of this figure. But the faster way to do it is to use multiplication. 27 times 8 is going to be equivalent to 216. So since the formula to find the area of a rectangle is base times height, I can multiply the base times the height to quickly see how many square units I'm going to have in this figure. So it's going to be 126. And since this base is 8 by 27, the area of this, I know the area of this one is going to be exactly the same because they're taking up the same amount of space. Now I need to find the area of everything else. So I have 126 plus 126. That's not my final surface area because that's not the area of all of the surfaces of this rectangular prism. So I need to find the area of the top and bottom base. So if I were to draw the little cubes, 8, I need 8 going along the height, 1, 2, 3, 4, 5, 6, 7, 8. And then I need 18 going across the bottom, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. If I were to draw all of the little squares that I needed to fill 18 by 8, I can see how much space this is taking up. But that's going to take too long. How many square units? Square units, because it's squared. Area is always to the second power because it's centimeters times centimeters. And that's how you end up with centimeters squared. How many times is the base a repeat factor? Twice. 1, 2. So that's where the 2 came from. But I can easily multiply 18 times 8 to find the area, how much space this figure is taking up, and that's going to be 144 centimeters. Now I need to, if this is 18 by 8, this top base is going to take up the exact same amount of space, 144 centimeters. That is still not my surface area because I need the area of all of the surfaces and then add them together. So now I need to find the surface area of my front and back face. So if I draw 18 little squares going across the bottom and 27 little squares going across the top, I can see how many square units is this figure enclosed. So if I add it or if I multiply it, I can get the answer faster. So it's going to be 486 square units. And since the area of the front and back lateral face are exactly the same, I know since they have the same base and same height, they're going to have the exact same area, which is 486 centimeters squared. So now I have the surface area. I have the area of each of the surfaces of the three-dimensional figure, all 6 face. So if I want to find the area of the surfaces, I need to add up the area of each face, and then that'll be my answer. So I have my front and back. Well, I'm going to do my left and right. My left face, my right face. So that's going to be 486 plus 486. And then I have my front face, which is going to be 200. Well, actually, I switched that up, but it's okay. I have 216. And then I have my back face, which is another 216 because they take up the same area because they have the same base and height. And then I have my bottom base, which is 144. And then I have my top base, which is also 144. Now, if I add the area of the surfaces, I'm going to get the surface area. So I'm going to put these numbers in. And once I add it up, I end up with 1,692. And then area is always two-dimensional, centimeters times centimeters, centimeters to the second power. So that is how you end up finding the surface area of the rectangular prism. You have to just find the area of the surfaces. So I'm going to put 1,692 centimeters squared, and that is how you complete this problem.